Hi all, in this video we are going to solve our third question in Cycloid. The question is, a circle of diameter 50 mm rolls without slipping on a horizontal floor for first half of the revolution. Then it rolls on a vertical wall for the second half of its revolution. Draw the curve traced by a point P which is initially at the bottom of the circle touching the floor. So here the circle first rolls on a horizontal floor for first half of the revolution, which means for 180 degree of rolling, and then it rolls on the vertical wall for the second half of its revolution, that is another 180 degrees. So total the circle rolls 360 degree. On the first half the circle rolls on a horizontal floor, and on the second half the circle rolls on a vertical floor. So we have to trace the path of a point P, which is initially at the bottom of the circle, which is touching the floor. So first I am drawing the initial position of rolling circle of radius 25 mm. CA is the center of the rolling circle. Now I am going to divide the rolling circle into 8 equal parts, that is 45 degree each. Okay, I am marking points as 1, 2, 3, 4, 5, 6, 7 and 8. And the radius is 25 mm. So the distance covered for 180 degree of rolling, that is first half of the revolution, it is pi r, that is 78.5 mm. So now I am drawing the locus of the center point for first half of the revolution, that is rolling on the horizontal floor. Okay, now I am measuring the radius 25 mm and I am drawing the position of rolling circle after 180 degree of rolling. Okay, now I am drawing the fixed line which represents the horizontal floor, that is for first half of the revolution, and now I am drawing the vertical wall, that is for the second half of the revolution. Now I am drawing parallel lines from 1 and 7, 3 and 5 and from point 4. Okay, now I am marking the position of points after 180 degree of rolling, that is after rolling on the horizontal floor. For the second half of the revolution, the circle rolls on a vertical wall. Here also the distance covered by the circle is same, that is pi r, which is 78.5 mm. So I am drawing the locus of center line for the second half of revolution. Okay, now I am measuring 25 mm and I am drawing the final position of rolling circle. Okay, now I am drawing vertical lines from 5 and 7, 3 and 1 and from point 2. Okay, I am marking the center point as CB. Okay, we divided 180 degree of rolling circle into 4 equal parts. So we have to divide the fixed line, that is the horizontal floor, also into 4 equal parts. So I am going to divide the fixed line, that is from point 8 to 4, into 4 equal parts. Okay, I am marking points as 1 dash, 2 dash, 3 dash, and 4 is already there. So now I am drawing vertical lines from 1 dash, 2 dash, and 3 dash. And I am marking this position of center point after 45 degree of rolling, that is C1. After 90 degree it is C2. After 135 degree it is C3. And after 180 degree it is C4. Okay, now I am measuring the distance CA-C1 on compass, and using that distance we can cut R from C4. That is the new positions of center point, that is for the second half of the revolution. And after 225 degree of rolling, the center position is C5. And after 270 degree it is C6. And after 315 degree it is C7. And finally after 360 degree it is CB. Okay, now I am marking the initial position of point P, that is the bottom point of circle touching the floor, and I am measuring 25 mm on compass. And from C1 I am cutting an arc on the line through point 1. That is the position of point P after 45 degree of rolling. And now from C2 I am cutting an arc on the line through point 2. That is the position of point after 90 degree of rolling. Similarly, from C3 and C4 I am cutting points, and I am marking points as P1 after 45 degree, P2 after 90 degree, P3 after 135 degree, and P4 after 180 degree. And I am drawing the cycloid through points P, P1, P3, P2, P3, and P4. Okay, now I am measuring 25 mm on compass, and from C5 I am cutting an arc on the line through point 7, and from C6 I am cutting an arc on the line through point 6, and from C7 I am cutting an arc on the line through point 5, and finally from CB I am cutting an arc on the line through point 4. So after 225 degree of rolling, the position of point P is P5. After 270 degree it is P6. After 315 degree it is P7, and finally after 360 degree it is P8. So now we can draw the cycloid for rolling on vertical wall, that is through points P4, P5, P6, P7 and P8. Okay, now I am marking the radius as R25, and the distance between CA and C4, it is pi r, that is the distance covered on horizontal floor, it is pi r. Okay, now I am marking the distance covered by circle on rolling through vertical wall, it is also pi r, that is the distance between C4 and CB. Okay, I am marking the rolling circle. I am naming the curve as cycloid. And now P is the initial position. And P8 is the final position. So in total the circle rolls 360 degree, For first half of the revolution, that is for 180 degree of rolling, it rolls on a horizontal floor, and for the second half of the revolution, that is for the remaining 180 degree of rolling, the circle rolls on a vertical wall. And this is the curve traced by a point P, which is initially at the bottom of the rolling circle, which touches the floor. And the curve traced by point P is a cycloid. So our drawing is completed. If you like the video, subscribe my channel and click the bell icon also. Thank you.